Good morning, friends. In the previous video, we were able to demonstrate the deadlock issue by writing this unit test, where we were creating two threads and we were changing these to from and to account to account one, for example. And this was causing the deadlock issue because there were two threads created and both the threads were trying to access to have this synchronized lock. So one thread was acquiring the first lock, and the second thread was acquiring the second lock, and both of the threads were waiting, trying to wait for the other thread to release the lock before they can proceed. And because of this deadlock, both the threads were locked at this point, and after that they were unable to proceed further. Now to fix this problem, right? There are quite a few ways where we can fix any deadlock issue. One way is that once we are creating this lock, right, instead of using the synchronized lock, we can use a try lock. So try lock has got an approach that they are actually done on the re-entered locks or the explicit locks, which is added in Java 7, I think. And after that, we can just use a try lock or a overloaded method of try lock with some time. After which, if it is unable to acquire that lock, which is it waiting for, it will just quit. It will do something else. So using the try lock, it would be easier because the thread will not keep on waiting there. As soon as it is able to acquire the lock, it will execute it will acquire the lock and it will execute the critical section. If it is unable to acquire the lock, it will just return. So that's the one way. But there is another easier way. So we don't want to do a lot of changes here. And the easiest way for this type of problem is that whenever a thread is trying to enter the critical section, for example, in transfer method, this is our critical section, we can actually make a sequence. That what is the sequence of the locks that has been used. For example, here there is no sequence. Whatever is the this or to method, I mean, whatever the accounts, because we are using account objects here, right? So if the account objects are whatever we are calling with this transfer method, that there's no sequence that this is the account that should always be acquiring this lock first, or acquiring this synchronized lock first. So this is where we can improve this and fix the deadlock issue. We can have a sequence pattern that the locks are always acquired in a particular sequence. And so where we can use this sequence, right? We are using account here, right? And here we have seen that there's an ID field, which is based on the counter. So for example, once we created these two account objects here, account 1 and account 2, the account 1 is having ID of 1 and account 2 is having of ID 2. And suppose there are many accounts here. So there would be always a scenario that one account ID is less than or greater than the other account. For example, if you are creating account 5, account 6, account 7, then account 7 would be having an ID which is greater than, say, account 5. Or account 5 would be always having an ID which is less than account 6. So based on that ID, we can generate this sequence of locking here in the transfer method. Instead of using this object and two objects randomly, we can check that we can have a sequence that, okay, suppose we can always acquire this lock when if its ID is less than the two account. If the two account is having an ID less than, say, this account, then we will lock that two account here instead of this. So this is what, I mean, we want to ensure that the first lock, say for the first synchronized block, which is happening here, that should always have, whether it's the account is from, which is this, or to whatever, it will always be having an ID which is less than. So if this account has got ID less than 2, then we will ensure that we will take this here in the synchronized block here. And similarly, if the ID is greater, then we will use this here, that account. Whether it's this or 2 doesn't matter. Suppose if 2 is having less, then it will use 2 here instead of this. And similarly, if this ID is less than the 2 account, we will use that. So this is how we are actually maintaining a sequence that whatever the account is having the less ID, that would be the first synchronized block. That is the first lock to be used. And similar and alternatively, the second would be having the higher ID. So let's write this program again with the deadlock fixed. So I will just copy this and use this transfer, say deadlock fixed. Just making this name, right? So now, as mentioned, that we are not going to use like a static like this, and two, we are maintaining a sequence here that whichever account's ID is less than the two account, that would be used in the first block here. So let's do that. So I will do that if say I'm using a ternary operator here. If this dot ID say is less than 2 dot ID, right? In that case, I would be using this as the first lock. Otherwise, it would be the 2 lock account, okay? And then I will assign it to a variable. Final, say lock 1. Okay. So whichever account is like whichever account is having ID less than the 2 account, that would be taken as the first lock, and this lock 1 would be used here. So lock 1 and lock 1. Similarly, for the other for the second block, I will call it as account 2, and here it would be again the same scenario that if this dot ID is less than 2 dot ID, in that case I will use the greater one as my second lock, right? So here we are actually maintaining a sequence here that just not based on that this or 2. We are actually checking the IDs first, so that every time it is following this particular sequence of acquiring this lock object. So again, I will put it here as lock 2 and lock 2. Here we are having a proper sequence of acquiring these 2 locks, lock 1 and lock 2. Okay, and rest everything should be exactly same, except that we are going to release this. So print release, that would be lock 2, right? And here it would be lock 1. Okay. So I think this should actually fix our problem. So let's actually create a new transfer deadlock fix method here as well, which can be called by the client. In our case, it's a unit test case. So I will call deadlock fixed, and I will call this transfer deadlock fixed. Okay. Okay, so as mentioned again multiple times, that we are actually maintaining a sequence here while acquiring the lock. It should be in the same order. How many number of times it is transferred with is called with whatever account is being passed here. So let's again run this test case, that whether it is actually solving the problem here. So the previous one was showing a problem, right? So this method 2 demonstrate deadlock fixed. Test deadlock fixed. Transfer, what was deadlock fixed? Okay. So again, just to revise here, that first of all, let me run this deadlock scenario so that we remember that what was happening there when both the threads were being locked, and it was unable to proceed further and do anything. So once we run this, we can see that there are 2 threads trying to acquire the locks, but they cannot proceed further because both are in a deadlock scenario. Now, once we run this, it should be able to fix this issue. So let me run this now. So previous one was heading into deadlock. Here I assume that everything should be deadlock fixed. Yes, perfect. So this is what the first transition was happening. So deadlock fixed, where we are transferring account 2 to account 1. So account 2 is this one. After this transition is done, and then the second thread which was created, we can see that there's a thread 0 which is doing the first transaction, and the second thread is doing the second transaction of this account 1 to account 2 of 30. So after this 150 was increased to 180, and similarly it was directed from this to 120. Okay. So if I run it multiple times, it's giving the same result, because there's no deadlock happening right now. Yeah, it's exactly same. Transaction was successful by the first thread. After that, the second thread was executed, and it was giving the same. Okay, so guys, let's revise this, what we have done so far. So first of all, we were able to demonstrate this deadlock issue because we were not having any sequence of acquiring this lock. Whatever was from account and whatever was to account, we are just creating based on those parameters and calling this synchronized block here based on this and to this is from, and this is synchronized to block is the to account where we are transferring the account. And if we are having multiple threads trying to do the same, in which the from account are and the to account are interchanged, we are having this deadlock issue. And we fix this problem by just maintaining a sequence of how this lock is being acquired. And that is done based on the ID field, which is associated with that account. So whatever is like from or to, whatever is the account, it doesn't matter. The sequence of acquiring this lock is always same because we are just based on the ID field. Whichever ID is less in both the accounts, that will be taken as lock 1. And whichever ID is greater, then it would be acquiring the lock 2. And that's why following this sequence pattern of acquiring the locks, the deadlock is not happening. And it's able to execute execute this critical section in a correct way without having any deadlock. So guys, I hope you enjoyed this problem and solving it with me. And now that I hope that you are like more aware of that what is deadlock and how to fix it. As mentioned, there are 2 ways: try lock and using the a particular sequence of how to acquire the lock. These are the 2 ways how we can make any type of threading code deadlock safe. So this was all about the third problem. In the next video, we'll cover problem 4, where we will implement a stack in Java. And there are various follow-ups after that we will be using Java collections without using Java collections, or bounded concurrent stack using logs, or concurrent stack using SAS operation. So see you all in the next video.